Three, two, one.
What is an argument? An argument is a set of initial statements called premises followed by a conclusion. So here's my argument. If you take the medicine, you will feel better. You did not take the medicine, therefore, you will not feel better. Let P, if you take the medicine, and let Q, you will feel better. So this is the symbolic form of my argument. P then Q is the first premise, and then not P is the second premise, and then therefore not Q is the conclusion. So how do we identify if our argument is valid or invalid? So in order for us to identify if our argument is valid or invalid, we must use the truth table. A truth table is a mathematical table used in logic, specifically in connection with propositional calculus, which sets out the functional values of logical expression on each argument. So we have here a table that has 5 columns and 4 rows. P, Q, and the first premise is P then Q. Second premise, not P, conclusion is not Q. In order to get the P, we must calculate 2 squared equals 4 divided by 2 so equals 2. So we have 2 true and 2 false for the P. So 2 divided by 2 is 1, so we will put PF in column Q. And in the first premise, T, because it's true, and false, T and T. Second premise, not P is false, false, T, T. And then the conclusion is not Q, false, true, false, true. So the conclusion is, in the 4th row, there are 3 truths. In the 3rd row, the first and second premises are true while the conclusion is false, which states that my argument is invalid.
Hello everyone, my name is Regine Abalispis from Group 2, and our topic for today is all about arguments. Argument is a set of statements or propositions which contains premises and conclusion. For example, if I pray, then I will feel ease. I don't feel ease, therefore I did not pray. So this is my symbolic form. First premise, Q implies E, and second premise, not E, and for the conclusion is not Q. So this is my truth table. For the first premise, true is equals to true, as true false is equals to false, and false true is equals to false, and false is equals to true. For the negation of E, true therefore false, and false therefore it's true, and true therefore it's false, and false therefore is true. For the negation of Q, true, so this is false, and true therefore is false, and false this is true, and false it's true. The 4th row, all premises are true, and the conclusion is also true. So this tells us that argument is valid.
I am Cindy C. Lucica, and this is my truth or trick. Let R represent the statement, watermelon is raw. And Q represent the statement, can be eaten. The symbol for the argument, if the watermelon is raw, then it can't be eaten. It is not raw, therefore, it can be eaten. So my argument starts here. If the watermelon is raw, then it can't be eaten. That is the first premise. So R implies not Q. then it is not raw, not are. And for the conclusion, therefore it can't be eaten. That is, therefore Q. So this is the entire argument, and it is in symbolic form. We should consider only two cases, the R and the Q. There are four cases here because there is only two statements in my argument. For the first premise, we have R, then not Q. R implies not Q. Look at the R and not Q. If true and false, it means false. And if true, true, false, 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 true, all are true. That is for the first premise. For our second premise is not R. So when we say not R, just negate this R. If true, then we have false. If true, then false. If false, false, we will have true, true. For the conclusion, we also have Q. Since we only have Q, just copy the Q in the table. True, false, true, false. And we're done. Because the conclusion in row 4 is false and the premises are both true, the argument is invalid.
Good day everyone, my name is Julian Biambike from Group 2. So this is my truth or trick. So my argument is let R represent if it rain and S represent street will be wet. So if it rain, the street will be wet. It will not rain, therefore the street won't get wet. In symbolic form, so our first premise, R implies is, and our second premise is not R, and our conclusion is not is. So this is my truth table. Our first premise, true, true is true, true, false is false, false, true is true, and false, false is true. So our second premise is the negation of R. So our R here is true, true, false, false. So it should be false, false, true, true. So our conclusion is the negation of S. So our S here is true, false, true, false. So it should be false, true, false, true. The truth table here is the row 3 and the row 4. So if the conclusion is true in every row of the truth table in which all the premises are true, the argument is valid. But if the conclusion is false in any row in which all the premises are true, the argument is invalid. So because the conclusion in row 3 here is false, and the premises are both true, and so the argument is invalid. So because our conclusion in row 3 is false and the premises are both true, the argument is invalid. So that's all. Thank you.
Okay, here's my argument. Let K represent a statement I will get a 15 on the quiz, and M represent a statement I will not fail. In symbolic form, the argument, if I will get a 15 on the quiz, then I will not fail. I fail, therefore I did not get a 15 on the quiz is. So here we have the first premise. If I will get a 15 on the quiz, then I will not fail. That's the first premise. The second premise, I failed. This. And the conclusion, therefore, I did not get a 15 in the quiz. So we have here the negation of K, because I did not get a 15 in the quiz. So here we have the truth table to determine if it is valid or invalid. First we have K, which represents the statement I will get a 15 on the quiz. We have here the M, which represents the statement I will not fail. And the negation of M, I failed. No, I will not fail. I will not fail. And we have here the first premise, the second premise, and the conclusion. So in K, we have true, true, false, false. In M, we have true, false, true, false. The negation of M, so the M here is true, so the opposite of true is false. False, the opposite of false is true. False, false, we have here true. So let's proceed to the first premise. So we have K, I will get a 50 in the quiz. True. I will not. Then I will not fail. False, which is false. So we have here the second row. Okay, true. We have here true. So our first premise is true. So third row we have false. False. The first premise is true. We have the fourth row we have false and true. So the first premise is true. So let's proceed to the second premise. Just copy the M. True, true, false, true, false. That's it. And now lastly the conclusion. The negation of K, because I did not study. So same here, we have that true, opposite of true is false. True, opposite of true is false. We have false, the opposite is true. False, the opposite is true. So okay. So all promises are true, and conclusion is also true in the third row. So my argument is valid. the third row, all premises are true, and the conclusion is also true. This tells us that the argument is valid. So my argument is valid.
Good day. My name is Pretty Joy Mendoza, and I am to represent to you my argument. Variable P is represent go to the movies. Variable Q represent I do my homework. This is my argument. If I go to the movies, I will not do my homework. Then I do my homework, therefore I did not go to the movies. Expressing the symbolic forms. P, if, and then Q is the first premise. Not P is the second premise. Therefore, the conclusion is not Q. And here is my truth table. They have 5 columns and 5 rows. First column is P, the second column is Q, the third column is P, if, and then Q, the fourth column is not P, the fifth column is conclusion. First column is true, true, false, false. The second column is true, false, true, false, because this is the original pattern of first column and second column. The third column is true, false, true, true, because if P is true, Q is false, only be false. The fourth column is false, false, true, true, because of negotiation of variable P. Last is the conclusion. Conclusion is Q, so you should copy the variable Q. True, false, true, false. Therefore, the statements are invalid.
Hello sir, good day. I'm Irene Bangkali Mendoza and I'm about to present my truth or truth activity. So let's start. Let P represent the statement study before the exam and Q represent the statement pass the exam. So our argument here is if I study before the exam, then I will pass the exam. I did not study before the exam, therefore I did not pass the exam. So our first premise here is if I study before the exam, then I will pass the exam. The second premise is I did not study before the exam. Then the conclusion is therefore I did not pass the exam. By the way, this is a conditional statement. As you can see, this is the symbolic form of our argument. P implies to Q, not P, and conclusion, not Q. So in order for us to identify or evaluate either our argument is valid or invalid, we will use a truth table. So we have here a table with 5 columns and 4 rows. And in each columns we have P, Q, first premise which P implies to Q, second premise not P, then conclusion not Q. So to get the value of column P, we need to calculate this one. 2 squared is equal to 4 divided by 2 which is equal to 2. That's why we have 2 true and 2 false. Next column Q, we will just divide 2 divided by 2 which is equal to 1. Then we have true, false, true, false. Next column is first premise which P implies to Q. So true, true means true. True, false means false, and false, true, and false, false all means true. Next column is second premise not P. We will get this value by just negating the column P. Next column is second premise, not P. So in order to get this value, we need to negate the value of column P. So true became false, true became false, false became true, and false became true. Last column is conclusion, not Q. So we will get these values also by as we negate the value of column Q. So true became false, false became true, true became false, and false became true. So as you can see, in the third row of conclusion is false, while both first and second premise is true. Therefore,